Recall through physics, when two crests meet each other, it results in a supercrest. You add or subtract the waves to get the resultant of wave interference. When we give those waves names, which are functional expressions, the resultant wave is then called the sum or difference of functions. For example, suppose we have two waves, one with functional expression fx equals sin x, and the other one is gx equals 2 sin x. The crests of the two functions with heights 1 and 2 add up together and result in a supercrest with a new height of 3. The same thing also happens to the troughs. Notice that the crests and troughs have the same x-coordinates to each other, and a resulting graph is obtained purely by combining their corresponding heights. This technique is called superposition principle, which states that the sum and difference of two or more functions can be found by adding or subtracting the y-coordinates, also called ordinates, at each x-coordinates, or abscissa. So, how do we represent this new graph? The special notation of the function is that f plus gx equals fx plus gx for adding of functions, and f minus gx equals fx minus gx. According to our class special need, now we'll randomly select individuals to repeat it 5 times until it sinks in your mind. Thomas, what is the notation for sum of functions? There are two methods to solve problems of sum or difference of functions. One is graphing, and the other one is solving algebraically. Let's look at a simple problem that can be solved by graphing first. The graphs of fx and gx are shown below. Graph and label the difference of these two functions. Using superposition principle, we can randomly pick 2 points with the same x-coordinates on a graph and subtract them. For example, we pick points with coordinates 1, 3, and 1, 7, and the corresponding point on the new graph would be 1, 4. Then we pick another pair of points, for example the y-intercepts 5 and 2. 5 subtracted by 2 will give us 3, so the next corresponding point would be 0, 3. Since the graphs of both fx and gx are straight lines, we know that the graph of their difference would also be a straight line, and that's why we can pick only 2 points to determine the behavior of the graph. But just note that, depending on the types of graphs that are combined, sometimes we may need to choose more than 2 points to get a new graph. Now let's look at a more advanced problem that may be solved easier algebraically. Let fx equals 1 over x, and gx equals x to the power 4 plus 3x cubed plus 2x squared plus 1. Find the domain of f plus gx. First, we look at the domain of each function. For fx, the domain is x cannot be equal to 0, and for gx, the domain is x belongs to real numbers. The domain of their sum is the common region of the two separate ones. So in this case, the domain of the new function would be x belongs to real numbers, but x cannot be equal to 0. In short, an easier way to remember how to find the domain of combined function is that df plus or minus gx equals dfx union dgx.